Good morning.
Good morning. Is that enough light?
There's actually a glare
Yes.
on the first problem.
Oh,
I
yeah.
can't really see the whole problem.
Well, that's the light at the top of the room, so I can't get that out of there. But it's also on what I sent you. Let me do this. On the warm-up that I sent, I attached it to the invite. So let me just move it down a tad. Yeah.
Oh. Is that something?
There.
Oh, wow.
Yeah, I don't have any control over the one on the ceiling. You know, here in the Math Cave Studios, you got to work with what you got. It's like it is exactly like when you're working back in the classroom, and I walk in and somebody from the night before has opened up all the blinds in the second story classrooms, and there's nothing but glare on the whiteboards, and nobody can see me. But this time I can't control it. Okay, so this is exactly your quiz, just different problems for Thursday. So on Thursday, you're going to have a graph the function quiz, a linear function, and you're going to have write the linear function that's either parallel or perpendicular to a given line. So just like this warm-up that we're doing right now. So let's look at the queue. When I send you the review sheet, not the review sheet, when I send you the YouTube link today, I'm going to attach, and it's a 6-page PDF document, 6 pages. 3 pages are problems. It's basically a 3-page worksheet. And then 3 pages are solutions. Now, here's the unfortunate part. I've made this a long time ago, and I just don't know which one is which. And so you'll have to forgive me. But one of these is worksheet A, the other one is worksheet B, the other one is worksheet C. These are not homework. No, they're not extra credit either. They're not homework, they're not extra credit. What this is to get you completely familiar with the quiz that you're going to take next Thursday. The quiz you're going to take next Thursday is 5 problems, all graphing. This first question right here, that's a linear equation. How do you know it's a linear equation? Because you have an x to the first, you have a y to the first equal to a number. That's standard form. Hopefully you solve for y. And if it's linear, just like the directions say up here, you only need to plot 2 points, plot and label 2 points, and then you draw your line. And then today you're going to learn how to graph and label the rest of these things. But there are 5 problems. And you're going to graph and label, graph and label, graph and label, these 5. And then right after that page, you get the solution. Basically what I'm looking for. Now, if it's a linear equation, you only need to plot 2 points. You do not need to plot more than 2, just 2. Now, if you plot more than 2, understand this. If you plot a point that is not on the graph, even though you have 2 points that are, if you plot an extra point and it turns out it's not on the graph, you lose a point because it's not on the graph. So remember, if you only need 2, then only put 2. Some of you found that out when you looked at your test. If you saw my email, I returned your test to you. Saw the email over the weekend. I returned the test to you. It was Sunday. I returned the test to you on Sunday. I apologize for it taking so long, but Friday, I decided to spend the afternoon Friday with my family. So I apologize for that. But anyway, you only need to plot 2. Got to label it. Some of you still aren't, you're not understanding what I mean by label. Ordered pairs on the graph, not up here, not up here. You can't just list ordered pairs up here. So I don't know if you're actually, maybe the people I'm talking to aren't actually, right now there's 22 people in the class and only 20 people are here right now. Maybe the people I need to be talking to aren't in the class, or maybe they've logged in, but they're not actually watching. Maybe they went back to bed. Who knows? I don't know. Couldn't tell you. But when we do these other graphs that you're going to be seeing, you got to show the work. And you have to plot at least 3 or more to generate a decent graph. At least 3 or more. Okay. Now, some of you on the lines, you're graphing fractions. I don't know why you would want to graph fractional pieces, but some of you are. Okay, some of you are. And let me do this real quick. Didn't I say you shouldn't change the scale on the XY axis of those boxes? Yes, no?
Yeah, you told us.
Yes.
You never ever need to change the scale. -7 to positives. I mean, have I said that a lot?
You said it enough.
Okay, and I mean, I need, you guys got to understand from my perspective, I've got 3 Math 103s. So I know I've said it a lot because I've got 3 Math 103s. So I know I've at least said it once in every class. I know I probably have said it multiple times in every class. But I still had students changing the scale, counting 2, 4, 6, 8, 10. And all that does, well, what they did was they changed the scale on one axis, but didn't change and counted by 1s on the other axis. So they counted by 2s on the Y and counted by 1s on the X. Well, all that's going to do is, especially with these graphs that we're going to be making today, the parabola, absolute value, square, that's just going to make them look horrible. And you're not going to get the whole concept of what it's supposed to be about. You don't need to change the scale of the little squares. Everything is going to fit, counting the boxes 1 at a time. Little squares, each one, 1, 2, 3, 4, all the way to 7 to the right, -7 to the left, up 7, down -7. So you're going to get this as an attachment when you get the YouTube link today in the email. And again, this is just basically, this is exactly what your quiz looks like. Now the problems will be scrambled. Maybe the first one is the absolute value and the third one is the line and the second one is the parabola, it's all scrambled up. That's all. But they come with the solutions, so you know exactly what it should look like. So you get an idea of what I'm looking for, the work looks like, everything that goes with it. Okay. Just like a review sheet for a test that you get when I give you the answers. This is an example of the review sheet for this quiz. Not this quiz on Thursday. This is for that. What I'm saying was, why are we using function notation? Basically, just an explanation of why function notation when y is just as good. If function f of x replaces y, and they mean exactly the same thing, why do we need it? And the reason is this, is when you have multiple equations, and you got to remember, we are not necessarily going to be in just a vacuum. you're going to have multiple things as you progress, as you gain knowledge, you're going to experience multiple things happening at the same time. And a lot of the times you want to compare one type of graph or situation to another. So one way of labeling one distinctive equation from another equation, if they're both called y, so if you have y equals negative 2/3 x plus 5, and you have a second equation, y equals 5/2x minus 7, and you graph each one, how do we know which y is which y? So we don't want to have to write out the whole thing and label it with the whole equation. So if we change the labeling to this is now called f of x, and let's call this one g of x, then when you graph each one on the same coordinate plane, you can just label it, this is f and this is g on the same graph itself. And you can put multiple graphs on the same graph. So in other words, and I know that a lot of you may never see this class, and that's perfectly fine. But to bring in an example of where you might see this would be in the class of calculus. The position of a function would look like this. It would be s of t. So instead of a y, we use the function s for position. S of t would be equal to something like negative 16t squared plus 9t plus 8. And it may look something like this. And that's the position of the function. The velocity at any given time, the velocity of the function, v of t, would be negative 32t plus 9. So the velocity of the function may look something like this. And the acceleration of the function, the acceleration a of t, how fast is its velocity changing with respect to time, would be negative 32 feet per second squared. This is in feet, this is in feet per second, this would be in feet per second squared. So the acceleration of the object would be at negative 32, and it's a constant. So we could now label this as its acceleration a of t, and then we can label this one as its velocity v of t, and you can now label this one as its position s of t. So you know exactly which graph is which, and which one is telling you this is your velocity, that's position, that's the acceleration. And how they interact with each other at the same value of t on the horizontal axis. That's why we use function notation. Plus, it makes something nicer happen. Instead of having to use a table every time you want to plug in numbers, instead of using a table, you can just go S of 5 and plug in 5, S of 4, plug in 4, S of 3, plug in 3. And because, yeah, you can have a line given here in standard form, function notation is always y by itself. This is always in slope-intercept form. So this is always in the quickest, easiest way to graph that we want. You don't have to go and try to solve for y first. It's already y by itself every single time. Okay? That's why we like function notation. Okay? All right. So now graphing this one. So recognizing that this is just the same as a y equals negative 2/3 x plus 5. So realizing the slope of this line is, what is it?
-2/3.
Negative 2/3.
Negative 2/3. And the y-intercept is 5. So much better this semester than previous semesters. There was only, in all 3 classes total, less than a handful of people that put the y-intercept on the x-axis. There was less than a handful total out of all 3 classes. The y-intercept is on the y-axis. Here's your y-axis. So it's at 5. So 1, 2, 3, 4, 5. Label that. And again, you only need to use a single number. No parentheses around single numbers. Some people, you're using ordered pair, which is 0, 5, which is perfectly fine. There was a few people that put 5, 0. 5, 0 is over here on the x-axis. It's not up here. So that's why that would be wrong. So now the slope is how you get from one point to the next point. So this is what I didn't understand from some people. You plotted the y-intercept, and then I understood what you were doing. You wanted the x-intercept, so you let this equal 0, and then you were solving it for the x, and you're getting fractions. That's not how we ever did this in class. That's not how I ever showed you how to do it. This is how you would do it the very first time you were learning how to graph a problem. But then we evolve and we want to do it by just counting the slope. The rise is -2. So from this point, you go down 2. So from 5, if you go down 2, you're at 3. And the run is +3. So you go down 2 and you go right 3. Down 2, right 3 puts us right here. The location of this point, x is 3 and y is 3. So there's your 2 points. That's all you need to graph your line. Draw your line and don't forget your arrows. And I don't think anybody forgot their arrows, so that was good. So there will be one on Thursday's quiz, function notation. You got to graph it. Okay, any questions?
No.
Okay. All right. We want to write this one using function notation. So the final answer in function notation, g of x. So final answer is g of x equals mx plus b. So remember what that means. You're still going to find it in terms of slope-intercept form, y equals mx plus b, but then at the very end, you're going to find y equals mx plus b, but at the very end, you're going to replace y with g of x. That's all. Perpendicular to this line, and it goes through the point 15, -5. So it's going to go through 15, -5, and we want the perpendicular slope. Now, that's not guaranteed that it's going to be a perpendicular question on Thursday. It could be a parallel, or maybe it's a perpendicular. If it's perpendicular, there's 2 harsh P words or P syllables. That means you got to do 2 things for the slope: opposite and reciprocal. Even those 2 things, opposite and reciprocal, have 2 P's in it. that you got to worry about. Opposite and reciprocal. So perpendicular, you got to do two things to it, opposite and reciprocal. When it's parallel, the slopes are equal. So I need my slope, which is perpendicular, so it's the opposite and reciprocal of this slope. So you have to find this slope first, which means you have to solve for this y. So you gotta show this work. We're going to subtract 9x. And that leaves a positive 12y equal to a negative 9x and a positive 48. Then divide everything by 12. And so y is equal to a negative. Simplify the fractions. Simplify that fractions. This is 3 times 3 over 3 times 4. So the 3's reduce. So your equation over here is negative 3 over 4x plus 12 goes into 48 4 times plus 4. That's the equation of this line in slope-intercept form. But all we care about is the slope. What's the slope of this line over here?
Negative 3 over 4.
Negative 3/4. So the perpendicular line is
Positive
4 over 3.
4 over 3.
negative 4/3. Positive 4/3. So now we have our slope. Step 1, find the slope. Step 2, is that a special case? Nope. It's not 0. It's not undefined. Step 3, write down y equals mx plus b. Plug in the slope. Plug in your 4/3. Y equals 4/3 x plus b. And I noticed that there's quite a few of you that are using y minus y sub 1 equals m times x minus x sub 1. There's quite a few of you that are using point slope form, but you are not showing how this becomes the final answer. You're plugging everything in, but you're not showing the work on this side. And that's why you're losing some points. Okay. I need an x and a y so I can solve for b. This is the only x and y I have. X is 15. Y equals negative 5. So negative 5 equals 4/3 times 15 plus b. So negative 5. 3 goes into 15 5 times. 4 times 5 is 20. So to solve for b, all you got to do is subtract 20. Negative 5 minus 20, negative 25 equals b. So you plug it in, y equals 4/3 x minus 25. Now, on the test you just got back, when you're not showing the work, they show, how you get from this, plugging in y is negative 5, so this is what I see. You have 15, -5 right here. So I see this. This is the step that I'm seeing students do. Y plus 5 equals mx minus 15. This is what I saw on so many students' test. Exactly this exact same thing. Now, for some reason, multiple students wrote exactly the same thing out and left off this parentheses right here. Now, why would so many students leave off this parentheses right here? I can only, I mean, the only way I could, my mind goes into places where I don't want to go. If they're all writing the exact same thing, I mean, they wrote exactly the same thing. And whenever students write exactly the same thing, I start to think bad things. Oops, 4/3. My bad. When they don't close off the parentheses. Not that technically you can still get the right answer. I understand what you probably needed to do. But when I see so many of them write exactly the same thing, it's like, wow, you might as well just submitted one exam, because I'm grading the exact same thing for everybody. And then the next thing I see is y plus 5 equals 4/3 x minus 20. And I'm going, how? Work. How did you get this from here? Because I know you wouldn't let me get away with just going from here to here in class. Where'd the 20 come from? And again, not just one student, not just two students, not just three students. I'm talking like 5 or 6 or 7 or 8 out of my 60, no, out of my 70 something students, a third. So you got to understand, when you wonder how can he catch people that are cheating, clues. Very easy to find clues. You're all going to the same website. So I don't want to be a jerk. I don't. But I want you to learn. I don't mean I want you to learn about not cheating. I want you to learn the material so you don't have to ever worry about being called on the carpet for it again. That's all. So just heed the advice. That's all. Okay. I have my list. My list has names. So this is some of you have a check. And if you ever want, like I said, when I sent the email out, if you want to discuss anything about your test, before class, right after class, since I try to let you go 10 minutes early, that's fine. During an office hour, that's fine. If you want to do a one-on-one Zoom, I can do that. you want to do it private, perfectly fine. I will be happy to talk about it with you. But my bottom line is to teach. And I can't teach if you're not willing to learn. You got to be willing to learn. And I know some of you are, you're math haters. I get it. But, I don't care. I'm not going to reward you for you not knowing your material, for you not knowing it. I always think about it looking at, from this perspective. What would you want your own child to be doing? And if you answer it honestly, hopefully it wouldn't be to fake their way through it. Hopefully you would want to set the right example. I'm just here to help you. And if I can't help you, then give me at least a chance to help you. Okay? All right. Enough said about that. Okay.
I had a quick question, Mr. Esquivel. I wasn't sure if you were finished with this problem or not, but
yes.
the final answer should have been in G of X.
You're right.
Oh,
Because
yeah.
right now I just lost, out of 5 points, I just lost 2.
Yeah.
Okay. First of all,
G of X.
because when I say I lost 2, what do you mean lost 2? Because there is more than just f of x as a function notation. If you go, hey, the answer is f of x equals 4/3 x, the directions did not say f of x. Always read directions. So if you put f of x, the question says no, not f. Final answer in g of x. So you're going to replace y with now final answer g of x. And that's all you do is replace y with g of x equals 4/3 x minus 25. Very good. Good call. So that means, look at that. See, so here's if you're doing a Scantron, if it's a multiple choice test and you have a Scantron and you bubble in 2 answers on the Scantron, what's going to happen?
It's gonna be wrong.
It's going to be marked wrong. Which one is it? You can't bubble in A and D. So that's the final answer. Now, technically, I would take the most correct of your 2 answers because I'm not a Scantron machine. Okay. All right. Any questions?
No, great.
Okay. This is exactly what you're going to see on Thursday. Okay. Questions from homework 8.1. Any questions from 8.1's homework? We've already done, well, I don't know, majority of them. Let me see here. Let me pull it up. What we have done and what we haven't done. So I see the question in the chat. Homework is due, all of it, for chapter 8 and chapter 9, all of it is due the day of the exam. So I need to change the date in the homework because right now it's not. It's not on there on the 4th. So I will change that when I get a chance to do it. But homework is always due the day of the exam, not the quizzes. And that's just always been my own personal philosophy because I know you guys have other things that you got to take care of. So the way I try to keep you on your toes is to, do the quizzes, as much as time gives us to do quizzes.
Is number 11 on the 8.1 homework what we just did?
You got it.
Yes, I was going to ask that one too.
Number 11. There you go. There we go. Good. Okay. Yeah, this one's going to come out with fractions. So this is a good one. I'm going to pause the recording. They're not going to come out to be ugly fractions.
Call them and see what time your appointment is.
Okay, well, I'm in class right now. So,
Now, that doesn't mean on a bonus question, it can't be
You
a
have to call
fraction.
them and reschedule.
yeah, I know. Bye-bye.
You know, bonus questions are always up for grabs. Everything is good to go. So through 7, -5. And this one is perpendicular to 4y equals x minus 8. Oh, this one's not that, oh, my bad. This one's actually not that bad. This one's not going to be fractions. Now, if it said parallel, it would have been a fraction. So perpendicular. So the slope of our perpendicular is going to be opposite reciprocal. So I need to get y by itself over here. To get y by itself, everybody gets divided by 4. Everybody gets divided by 4. So now you have y equals, remember you can write x over 4 as 1/4 x minus 2. So actually this one's not that bad. So the slope over here is positive 1/4. So what's our perpendicular slope?
-4/1.
-4/1, but simplify it. What is -4/1?
Just -4.
Just -4. Just a -4. And they want f of x notation. Final answer is going to be f of x equals mx plus b. So not a special case because it's not 0, it's not undefined. So now we go to y equals mx plus b. Plug in -4 for the slope. So y equals -4x plus b. The only point we have is 7, -5. So we're going to let x equal positive 7. Y is -5. So -5 equals -4 times 7 plus b. So -5 equals -28 plus b. Add 28 to both sides. -5 plus 28 is 23. So there's the y-intercept. So this b is positive 23. So there's your y equals -4x plus 23. The final answer is supposed to be f of x equals -4x plus 23.
Hello?
Yes. Hello?
Yes, this is she.
I can hear you.
Good, how are you?
I'm okay. How are you?
Tomorrow at 11?
Yeah, I can make that.
Okay. Yeah, I'll be able to go there, yeah.
And then can you do number 1 really quick? I think I just overlooked.
Yes, for sure.
Okay.
All right.
Number
you.
1.
Bye.
So on this one, it says f of x equals just 6x. So if we match this up with y equals mx plus b, all we have is m. B is 0. Do you see why b is 0?
Oh, yes. Okay.
So it's going to go through the origin. So the line's going to go through the origin. So that's the first point I'm going to click on. And the slope is 6 over 1. So you go up 6, and then we go right 1. Oops. So the ordered pair at up 6 and over 1 is at 1, 6. And that's where the line goes.
Oh, okay. Okay.
Okay. Any others?
On 8.1, but it's just a fast question for 8.3, the very first question.
We're not ready to go all the way to 8.3 because I got a lecture on the rest of 8.2.
Okay.
So I want to finish 8.2, and then on 8.3, the piecewise functions, that's going to be the end of today. Yeah.
Okay.
Is there anything on 8.1? And then on 8.2, we did, look at all we did. We did 1 through 3, well, we did 1 through 6, we skipped 7, we did 8 through 13, and then we did number 17, and then the brand new graphing questions are 14 through 16 and 18 through 20 we have to do. Those are the ones we have to lecture on. So is there any question on the ones that we did or number 7? Just in other words, leaving out 14 through 16, leaving out 18 through 20, because those need lecture right now.
When did we do 17?
We did it on Thursday because it's just a line. So take a look at this. Similar question. So look at the function is 2x minus 5. So compared to the previous 3 problems, compared to the previous 3 problems, 14, 15, and 16, those are all equations that we've never graphed before. X squared, 14, 15 is absolute value. We haven't done that yet. 16 is another x squared. We haven't done that yet. But 17 is 2x minus 5. That's x to the first. This is a linear function. We've graphed this. We know the picture is going to be a straight line. So since these are multiple choices, automatically, you know you can eliminate C and D. So now it's either A or B. So without graphing, you don't need to worry about doing the graphing. You need to recognize what's the slope of this function.
Positive.
Positive 2.
Positive 2.
Only one of these lines has a positive slope. Is it A or is it B?
A.
A. So the only possible answer is A because it rises. The line rises.
Yes.
So you don't even have to worry about actually doing the graphing by hand. You need to be, and by the way, and you might want to file this in your brain or maybe write yourself a Post-it note. The final is multiple choice. You can try to do all of the graphing by hand and then finding the answer for it. Or just like I showed you right now, you don't have to do any graphing. You just got to be able to tell the difference. What makes this one the answer instead of B? The slope is positive, so it needs to go up to the right. It needs to rise versus B where it falls. It goes down. And there's process of elimination. It can't be C or D.
Oh, wow.
Okay.
Okay. Yeah.
Okay.
Hmm.
So let's get the lecture going. Let me see. I'm going to look at right now, just real quick. You said A3 number 1. Just want me to look at it real quick. Yeah, it's graphing, it's multiple choice, so I have to do the whole. I'm going to do the whole thing.
Is it just because I was looking at the examples and then I saw all you have to do is like plug in the numbers. I just don't understand like that last part of like the x is greater or equal to than 0.
Well, so in a piecewise function, you see how it has two equations up here, f of x equals, and then you have two pieces, the
Mhm.
first piece, second piece. So f of x is equal to 6x plus 5 if you plug in x's that are less than or equal to 0. So on a xy axis, if you use x's to the left of 0, you're going to plug it into this equation.
Oh, so like
And for x's that are greater than 0,
plug it into
you're going to
this.
plug it into the second equation.
Oh, okay. So like I can use -1 and 1.
Yeah, you could.
Okay. Okay. Thank you.
Mhm. All right. So now what you're going to want to have is that graph paper.
Okay. Another page.
That where did I put it? Whoops. I put it in the announcements and I sent everybody this last week. This function table graphing paper, like so. That's what we're going to want to have. So, well, hopefully you're able to print that off because it'll help. While you're getting that out, if you haven't got it out already, chat check, and I'm going to put it up here on the board. All right. So over here, when you're graphing a linear equation or a function, you need to plot and label at least 2. Got that done. Plot and label at least 2 points. All other graphs require at least 3 or more points for accuracy. Actually, for my 2 words here are symmetry, and accuracy. So you have to plot and label at least 3 points for symmetry and accuracy. And we're going to learn how to plot parabolas, absolute values, square roots, and piecewise functions. So 4 more new types of graphs. They all have their special points that you have to find first. Just like a linear equation or linear function, the y-intercept is the first thing you should find. The y-intercept is your favorite friend. It's the most important point you could possibly find when you're graphing a line, because it's the easiest one to find. It's the b. All the other graphs, they have their most important points you have to find. Those are the ones you have to start with. Okay? So the first thing we're going to figure out is, it's called a parabola. Or if you want to break it down into its, its syllables, parabola. One of my favorite professors when I was at UCLA, way back in the 80s, Math 36A was the name of the class. Math 30, was it 36A or 30? No, it was 35A, 35B. No, Math 32A, Math 32A. There we go. Yeah, Math 32A. Dr. Sundararaman Durswamy. I could pronounce his name. Dr. Sundararaman Durswamy. And for about a week and a half, he was talking about the parabolas, the hyperbolas, and the parentheses. And I'm going to and it never occurred to me to actually look in the book or look at the homework to see what he was talking about. I wasn't the greatest of students back then. Or in other words, I wasn't the brightest of students back then. Parabolas. Parabolas. Hyperbolas were the hyperbolas, and the parentheses, parentheses. Now, his Indian accent was nowhere near as bad as the German chemistry teacher that I had. Dr. Barrington, oh God, could not understand his German whatsoever. UCLA was one of the most impressive institutions I have ever had the pleasure of attending, but my gosh. Yeah, quite a few of the professors are not from our country, and English is their 5th language because they speak so many of them. But the Eastern European professors were just, wow, their accents were so thick. Whew. The Germans, oy. I think they're still holding a grudge. I don't know. My wife is German. My daughter says I need to be more sensitive, so I probably should pause recording. Anyway, but yeah, the parabolas. The parabolas. This is where we're headed. It's going to look like this. F of x is equal to, there's going to be a constant. There's going to be some number a times parentheses x minus h parentheses to the 2nd power, and then plus some number k. So remember, f of x and y, they're the same thing. So it could be y equals, could be f of x equals. But here's the deal. Just like you have g of x equals mx plus b, and the m is the slope always. It tells you what the slope of the line is going to do, whether it rises, whether it falls, how steep it is or how shallow it is. And b tells you where it goes, where the y-intercept is. This a is going to tell us something about what the parabola is doing. This h and this k are going to tell us something about what this parabola is doing and where it goes. The square itself, the fact that it's a power of 2 instead of right now this g of x. Right now, we just don't write it, but it's x to the first. There's a 1 up here because x to the first is just x. You simplify x to the first and you just get x. So we don't put the 1, but there's always a 1. It's an x to the first. So a first degree is always a linear equation. If you have an x to the first right here, it's always linear. When you have x squared, it's always going to be a parabola. Now this x, remember, this is also y equals a x minus h squared plus k. This x and the y, those are the ordered pairs. Those are all the points that you would get when you plot the thing, when you graph the equation. These are your x's and y's. This f of x is just the y value. But the a, the h, and the k tell you where that parabola is going to go and what it's going to look like. So we don't start with this. We don't. What we're going to do is we're going to start with something simple. So on our table, we're going to start with f of x is just x squared. Just a simple x squared. Now, I'll point something out to you when I finish this. These are the numbers we're going to start with. We're going to start with, and this is how we start, no matter what you're graphing, you always start by plugging in numbers until we start to see a pattern, and then we start realizing it's always going to look like something. So I'm going to pick some numbers for us. We're going to pick -3, -2, -1, 0, 1, 2, and 3. That's what we're going to start with. So here we go. Plugging in -3. So f of -3, and this is going to burn some of you when you do this on an exam. When you substitute negatives, parentheses, x squared. So that means the whole thing, the -3, is going to get squared. So a -3 squared, a negative times a negative is a positive, and then 3 squared is going to give you +9. So when you plug in -3 for x, the y value is positive 9. So for right now, yeah, that's off of our grid, but that's okay. So here's -1, -2, -3. 1, 2, 3, 4, 5, 6, 7. Missed it by that much. 8, 9. So -3 goes in, 9 comes out. Label it. And then we plug in -2. So f of -2. So parentheses, -2 is going to get squared. Negative times a negative is a positive. 2 times 2, that's a positive 4. So when -2 goes in, we get positive 4. So when -2 goes in, we get positive 1, 2, 3, 4. So right here. Come on. There we go. So technically right now with 2 points, I would make a straight line, but watch. -1, f of -1, parentheses, -1, squared, -1 times -1 is positive 1. So when you substitute in -1, we get positive 1. So when you plug in -1, we get positive 1, which is right here. And if you look at this, you can see on my crude scale, they're not on the same line. If I draw a line between 2 points, the third one's not on it. Now that might be just because my XY axis sucks. But watch what happens on the 4th point. You'll see something happen. When you plug in 0, f of 0. 0 squared. 0 times 0 is just 0. So when you plug in 0, we get 0. Right here. And one more time, that's the origin. You don't have to worry about labeling the origin. And as you can see, if I draw between these 2 points, the other 2 are not on that straight line. So this is obviously not a linear equation or a linear function. If I draw between these 2, the other 2 points are not on that straight line. This is not a linear. It's something else. Especially when we get onto the other side. When we break on through to the other side. When we plug in 1, f of 1. So that's 1 squared. 1 times 1 is 1. When you plug in 1, we get 1. So here's what's been happening as we go from left to right and we plug in x's that get bigger, the y values get smaller. But then when we get to positive 1, they go back up again. So technically, if it was a straight line, they would continue going down. But this time they go back, they're starting to go back up. And that hasn't happened before in anything that we've ever graphed. And then we try 2, f of 2. And we get 2 squared. 2 squared is 4. So when you plug in 2, you get a 4. And wow, okay, so now it used to be going down, 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 decreasing, and now it's starting to increase. As x gets bigger, the y's get bigger. So on this side of 0, it's getting smaller, it's decreasing. The function's getting smaller, it's decreasing. And then as you go from 0 to this way, to infinity, the y's are getting bigger, the y's are increasing. And then when we plug in 3 squared takes us right back up to 9. Plug in 3, we're right back up here. So this is obviously not linear because you can't just draw a straight line through everybody. This is a curve. This is a curve. And it's called a parabola. If you were to plug in more values, less than -3, greater than 3, at -4, it's up here at 16. At +4, you're up here at 16. If you plug in the -5 and 5, 5 squared, -5 squared, they're up here at 25s. If you plug in the 6s, you're up at 36s. 7s will get you 49. 8s will get you 64. 9s will get you 81s. And 10, I'm up there on the roof at 100. Because when you square a number, they start to get really big really quick. So when you draw this graph, it is a curve. So when I draw my graph, when I draw the curve, I don't make one big curve like this. I don't draw it in one swoop. I tend to draw it from this point. I like to draw it like this. And there's an arrow. There's an arrow because as you plug in more numbers that go to the left, it continues to go up to the left, up to the left. So there's a little bit of a slant to the left. I'll point out what you shouldn't do in a minute. And as I continue to plug in numbers to the right, then I basically draw on each, one half to the left and one half to the right. And I draw this half this way. And as you can see, there's a little bit of a widening that continues. So it maintains that we're going to keep going to the left, we're going to keep going to the right, and they're going to keep going as they flare out this way. They're not going to flare out like this. It's not going to go like this. So it looks like it's curving like this. So you don't put a little curve to it like that. That's a no. And then here's the big no. Because you guys are drawing on a grid. Do not do this. This is a big no. And again, I wouldn't be saying this if I haven't repeated it a bazillion times in all my classes before, yet people still do it. When they draw their parabolas, they tend to do, plug in these points, and they plot and they label, they plot and they label, and then they draw the parabola like this, and then they go straight up the grid, like that. So it looks like that. That is a huge no. Because all you're saying is, when you plug in 1, it looks like every y value after that is always 1 because it's going straight up that line. What happens when you plug in 2? It should go over here with a 2. And when you plug in 3, it should keep going that way with a 3. You see that? See what I mean? So that's why it should have a little bit of an angle to it. That's why I say when you graph these other graphs, you want at least 3 or more points for symmetry and accuracy. The most important point you're going to plot is this guy. Now, again, when it's here at the origin, you don't have to label it. But this guy right here, where it changes from decreasing to increasing, that's the vertex. That's the vertex of the parabola. So when I show you the practices, right here, number 3, do you see number 3 right here?
Yeah.
X squared plus 2. The vertex is right here at this 2. That's where it changes from decreasing to increasing. And then this equation right here, the vertex is right here at 4, -3. So something happened when I wrote the problem in this form that moved the vertex from where it used to be 0, 0. It moves the vertex over here to 4, -3. And then you're going to see something like this, where now the vertex is up here, whoops, at -2, +4, but the parabola is upside down instead. But if you notice the symmetry, over here on the left, I have -3, +3. Over here on the right, I have -1, +3. Over here on the left, I have -4. Over here on the right, that's 0, 0, so I didn't label it. Over here on the left, I have -5, -5. Over here on the right, I have 1, -5. Symmetry. And it's all about symmetry about the vertex. And I'll show you what I mean in a minute. Okay. So that's the vertex. We'll explain more importantly what that means in a second. Okay, so there's our parabola. Obviously, if this was a test question, quiz question, you wouldn't be able technically to plot the 3 and the 9, -3, 9, because that would be bigger than 7. But you could definitely plot these guys. And that would give you enough to give you a good width so you could see exactly what it should look like. I'm going to redraw this. I'm just going to move it up a little bit higher. So don't go anywhere. Stay tuned. Now, this is what I'm going to do. First thing I'm going to do to change what's going to happen to this thing, to go to where we want to go, is I'm going to put a negative in front of that x squared. So instead of positive x squared, we want to graph negative x squared. So this is now going to be equal to negative x squared. And this is why your substitutions are so important that you are really careful with negatives. So this negative is not being squared, only x is. So when we substitute -3 into the function, it looks exactly like this. You have the negative on the outside. You have the negative on the outside. And then you have parentheses, -3 squared. So that's going to equal, the negative on the outside is still there. The negative on the outside, and then the -3 squared is a +9. So when you have -3 squared, you get -9. So when we plug in -3, we now get -9. We plug in -3, we get -9. Same thing happens when we plug in -2 now. F of -2 is equal to, there's a negative on the outside, and then you plug in your -2 and square it. So that's going to equal negative, and then that's a +4. So when we plug in -2, we get a -4. So instead of it being -2, +4, it's down here, -2, -4. So any prediction about -1?
It's gonna go downwards.
Yeah. Basically, when we just had x squared, if you plug in a positive squared is a positive. When you plug in a negative squared is a positive. That's why everything is positive here. Everything is a positive. Because when you square positives or negatives, everything is positive. But when you plug in a negative in front, when you put a negative in front like this, then all of those that are positives that come out after you square it, they are now upside down. They are now negatives because you put a negative in front of it. It's now the opposite of what you got. It's now an opposite of the square. The opposite of a positive is now a negative. So when you plug in -1, it's now the opposite of what you get when you square -1. So that's the opposite of +1, -1. Now, does it change anything when you plug in 0? No, because the opposite of 0 is still 0. But all that's going to happen over here when we plug in these, there's going to be a negative in front. So there's going to be a negative in front of the answer. So all of these are going to have negative y values. So over here, this is going to be 1, -1, 2, -4, and 3, -9. Don't forget the arrows. So this is negative x squared, and up here, this is positive x squared. And this is always true for any class, no matter what class you're in. If you change the sign of the function, if you put a negative in front of whatever the function is, it is always going to flip everything upside down. It's going to flip everything. Positives become negatives, negatives will become positives. So just on a side note, just on a quick side note, and I don't mean, I'm not doing this to like say, ooh, look at him, he's showing off. Just a quick side note. When you have y equals sine x, the sine function in trig, and you graph the sine function, the sine function does this from 0 to 2 pi. It goes up to +1, it goes down to -1. But when you graph y equals negative, you put a negative in front, negative sign. If I put a negative in front, then all of these y values that are positive are going to flip down, and all of these negatives have a negative in front, and a negative times a negative, they're going to flip up. So it's going to look like this. From 0 to 2 pi. A negative just flips everything. Always. No matter what class you're doing it. A negative in front of the function is just going to flip it. No matter what we're graphing. No, this is not going to be on your test. Ever in this class. But the concept is. The concept is. Now here's the deal. Here's a quick question. Out of all the players in our game, is this negative here? Basically, if you look at this, this is, write it in a different color. This is f of x equals, when you look at this, -1 times your x squared. That's a -1 times your x squared. Let me put it in parentheses, -1 times that x squared. That's this negative right here, -1 times the x squared. Is this -1, is it a y, an x, a y, or is it the a, the h, or the k?
Would it be the A?
It is the a. This -1 right here, this -1, you see how a is in front of what's being squared?
Yeah.
A is in front of the x squared, or the square. Right here. Where's
Yeah.
this negative? It is right here in front of the square. It's -1 times your square. It's the a times your square. So when you see this negative x squared, your a is a -1. this a in the function, it controls the ups and downs. A controls if it opens up or if it opens down. Opens up, opens down, up, down, up, down. Okay? A controls if it opens up or if it opens down. So piece by piece, one piece at a time. F of x equals a x minus h squared plus k. If a is greater than 0. What kind of numbers are greater than 0?
My favorite's number 1.
But no, but what kind?
Oh, real numbers, positive numbers.
Positive numbers. If a is greater than 0, positive. If a is greater than 0, positive numbers. When you're positive, when you're a positive person, you're a happy person. When you're happy, you're smiling. The parabola opens up. It opens up like a cup. It looks like a smile. If it's a positive times the square, it's going to open up like a cup. Up has a U, opens up. If a is less than 0, what kind of numbers are less than 0?
Negative numbers.
Negative numbers. When you're a negative person, you're kind of grumpy, frowny. The parabola opens down. The parabola opens down like a frown. So if the a in front is a positive, it's going to open up. If it's negative, it's going to open down. This is where I really miss the classroom, because in the classroom, I have 3 boards bigger than this to work on. So I don't have to erase everything every time. I can just build on what I have. Next one. F of x equals x squared minus 3. Since we know it's always going to look as our parabola shape, we don't need to plug in as many points to get the job done. We know it's going to look like a parabola because everything that is a square is going to be parabolic in shape. So I'm only going to use these numbers. I'm going to use -2, -1, 0, 1, and 2 for my parabola this time. I don't need as many. So f of -2. So first of all, what is the a in front of the x squared? What is the a in there right now?
Regular 1.
A +1. It's 1 times x squared. So since it's a +1, you know it's going to open up. We plug in -2. So you get -2 parentheses squared -3. And I apologize real quick. Just for reference, here is where we started from. Y equals x squared. This is our original. The OG parabola, okay, if you will. So we can just do a comparison. So you can see what the -3 does to it. So we get -2 squared is +4 -3, and +4 -3 is +1. So now when you plug in -2, we get +1. So now when we plug in -2, we're here at +1. So here's the thing. It used to be up here at -2 with a 4. But now it's at -2 at a 1. So x is the same, but the y value is at 1 instead of 4. I wonder what that -3 did. Don't answer that yet. So then we plug in -1. F of -1 is -1 squared, and then you take away 3. So that's +1 minus 3, and that gives us -2. So at -1, we're now at -2. So when we plug in -1, we're down here at -2. The last time we plugged in -1, we were at +1. This time we plug in -1, that y value is now here at -2. And then 0. So 0 squared minus 3 is 0 minus 3, and that's -3. The last time we plugged in 0, it was at the origin, 0, 0. This time we plug in 0, the y value is -3. It used to be here at a y value of 0, but now it's dropped down to here at -3. What happened to all the original y values? That 4 to this 1 to that -2, that 0 to this -3.
Could you ask that again?
What happened to the original parabolas y values? This 4, this 1, and that 0. What happened to the original y values now that they're here at this 1 and this -2 and this -3?
They seem to be lower by
How
3.
many?
By -3.
3 lower. Why are they 3 lower?
Because of that -3.
Exactly. We took the old y values. Remember, the function was just x squared, right? That's what we started with.
Yeah.
That's the original graph there in reddish pink. And then we're doing what? Take away 3.
So it just lowers everything by 3 then.
It takes, yeah, exactly. It takes all the old y values and drops the whole graph straight down, intact, drops it straight down 3 units. So it was like this, and then it just drops it down. Everybody loses 3. It's like being tackled behind the line of scrimmage 3 yards. Sack for a -3 yards. If you plug in 1, it's going to be 1 squared plus 3, or -3 still. So 1 minus 3 is still -2. So at 1, -2. But here's what I get about with symmetry. Once you know we have found the vertex, and I'll show you why we know this is the vertex in a little bit, then to the left, if this is -2, then to the right, you're going to know this is -2. And you don't necessarily need to do all the substitutions. You're going to let symmetry tell you what these are. Over here, if this is 0, -3, 2 to the left, the y value is 1. If you go 2 to the left, the y is a 1. Symmetry, that means whatever is here on the left is equal to the right. Left and right are the same. If you go 2 to the left, the y is a 1. So when you go 2 to the right, this y is going to be a 1. Symmetry. If I plug in 2, 2 squared -3, 4 minus 3 is 1. There's my 2, 1. After the square, if you take away 3, everything gets dropped down 3. What if it was a g of x? What if it was g of x equaled x squared plus a 2?
Would it be safe to assume everything's going to go up by 1 then?
Up by 1?
By 2, I should
By
say.
2. Your old, so the original graph is x squared. So that's this one right here. But then you take all of those problems, all of those y values, and then plus 2. So the whole graph is going to raise up 2 units. So instead of a 4, what would the y value be?
It would be a 6.
It would be up here to 6. instead of a 1, what would this y value be?
Three?
It would be a 3. At 0, you got 0. But if you had 0 in the old answer, what would the new answer be after you had 2?
Positive 2.
It would be positive 2. So on the left side, it looks like this. And then on the right side, if negative 1 will get you 3, then positive 1 is going to get you 3. If negative 2 will get you 6, then positive 2 would get you 6. Do you see how this is after the square? After the square has already happened. So we're going to do our police lineup. You already told me A is in front, right here in front of the square itself. So right here in front of the square, what is the A? What times x squared?
Positive 1.
Positive 1. We wouldn't write 1 times x squared. So if you don't see anything right there, it's a positive 1. There's a 1 times x squared there. But now, what do we have left? We have h and we have k. So what is that 3? Or in this case, what is this thing? What's going on here? Is this possibly h or is this possibly k?
Would it be k?
Exactly. You see how h is inside parentheses with x? That's where h lives. H affects the x. H hangs out with x. One more time. H hangs out with x. H and x have a relationship. H and x, x and h. K is after the square. K comes after the square. This 3, this actually negative 3, is after you've already done the square. So the K right here it's always got a plus in front of it. So if you see negative 3, then this K would have to be a negative 3. Because what are we adding to make this a negative 3? We'd have to add plus a negative 3 to get minus 3. Over here, K is a positive 2. Now, why are these things important? I'll show you. On the original graph, the vertex was at 0, 0. Right here, this vertex was at 0, negative 3. And right here, this vertex was at 0, positive 2. This K is a positive 2. That vertex has got a 2 in it, and that K is a 2. I think there's a connection. This vertex is at -3. That K is at -3. I think there's a connection. The most important point you got to plot when you do this graphing is you got to plot the vertex. Oh, K tells me where the y coordinate of the vertex is. This K is the y coordinate of the vertex. It's the y coordinate of the vertex. I wonder what H is. What do you think H is? Hurry up, because my face is going to freeze like this.
It's the X.
Yeah.
Oh,
X.
gosh. That was a shot in the dark.
Let's look. The X coordinate has been 0, hasn't it?
Yes.
This is what people struggle with. Inside parentheses, X minus H squared. What would H have to be so you just have X squared right now?
0.
Yeah, so if we do our little match game,
Makes sense.
f of X equals X minus H, my bad, A times X minus H squared plus a K. And if I just gave you this, if I just gave you f of X equaled 3 X minus 2 squared plus 4. And if I said, all right, what's the A? Out of the lineup, what's the A?
3.
A is +3. You would need to make a conclusion. This is going to open up. And then match game right here. X is a what?
0. Wait, what?
Right here.
A -2.
-2.
You see how that negative is right there? And we see a negative right here? X, then X, minus, then minus. H is?
Just H.
Exactly. Sorry, not X. H is exactly +2. I'm going to come back to this in a second. And what is K?
It's A.
4. +4.
K is exactly +4. All right. This is huge. H, so I'm trying to do this differently than I've done it before. So I'm running a little, you guys are my lab rats right now.
Nice.
If you just go straight down, matching it up, A is 3. There's X, there's X. I mean, everything for F, parentheses, X equals even matches up. So A is exactly +3. That means it's going to go up. And then the parentheses begin. There's the X, there's the X, there's a minus, there's a minus, there's an H, there's a 2. H is 2. That minus is this minus, so they kind of cancel each other out when you match them up. So H is that 2. H is a 2. The plus matches the plus, so K is that 4. So H is a 2. You see a minus, look what H equaled. What
How did
did
you
it
get the +2?
What's that?
How did you get the +2 for the H?
The formula has a built-in negative. In the formula, that is always minus.
Mhm.
Always.
Always.
And this is what you better just, you take out a drill
Oh.
and just put this into in that parentheses. It is always X built-in negative, x minus and then h.
So
So
positive.
x minus, what would h have to be in order to be an x minus 2? It would have to be a positive 2. Because the negative is right there. That's this negative from the formula. If it was, so now here I'm going to change it. If I gave you g of x equals, I'm just going to make this x plus 2 squared. So here's the matchup. A x minus h squared plus k. So in front of the square, a is a 1. After the square, is there anything after the square right here? Plus anything?
No.
Um,
A
Is there
0?
anything added or subtracted after your square right here?
No.
So what would k have to be for nothing to be there?
0.
K is a 0, but look inside the parentheses. You see the plus? Okay.
Yeah.
The formula is a built-in negative. The only way this could possibly come out to be a plus is because h is negative 2.
Okay.
The only way this comes out to be a positive 2 is because whatever you plugged in here, it went x minus, and then somebody plugged in negative 2, and then we squared it. H is a negative 2. A negative and a negative made that a plus 2. So H was a negative 2 to become a plus here. Let me show you why. I'm just going to go a couple of minutes more. And I'll show you why this is going to be important. Then I'll show you, just a little verbalization that'll help you remember which is which. So here's our original. We're going to graph f of x equals parentheses x plus 2 and squared. If I use exactly the same numbers, negative 2 goes in. Actually, my bad, not plus 2. I want to plug in minus. You know what? I want to do plus 2. Plus 2. Never mind. So f of negative 2. So that's parentheses negative 2 plus 2 squared is equal to 0 squared. So when we plug in negative 2, we get 0. We get this. Right there.
wait, can you go back? How did you plug that in? You put f negative 2 equals,
Negative 2 plus 2.
oh, negative 2 plus 2. Oh, okay.
Uh-huh.
Then we plug in negative 1. So that's -1 plus 2 squared, which is equal to +1 squared, and that's a 1. When you plug in 0, 0 plus 2 squared is 2 squared. When you plug in 0, we get 4. And if I plug in 1, it's going to be off my grid. 1 plus 2 is 3. And 3 squared gives me 9. When I plug in 1, I get 9. We're off the grid. If I keep going to the right, it's going like this. It's not going to come back down. So I shouldn't be plugging more numbers that way. I should probably be plugging more numbers this way. Like I should probably plug in -3 and seeing what happens. Because it's not going to come back down. Basically, it's futile to keep going that way. So I'm going to check -3 just because it's not coming out. So look what happens, -3. So that's -3 plus 2 squared. That's -1 squared, and that's +1. Okay, so -3 gives me, that's over here. So now we're looking at this. Wrong color. Now we're going this way. And when you plug in -4, -4 plus 2 is -2, and that gives us back to +4. So at -4, we get +4. So this x plus 2, look what it did from the original purple graph of just y equals plain simple 1x squared. It moved everything left. Plus 2. Wouldn't plus mean we go to the right? When you see plus, right? Makes more sense. You see plus, I'm going to go right. But it's moving to the left. I wonder why it's making us move to the left. And here's what I'm trying to get across. What plus 2 is 0? What plus 2 makes a 0?
-2, -2.
That's why the old original vertex, which was at 0, 0, is moving to the left. The shift is to the left, a -2 to the left. Because what makes us back to 0? -2 makes us back to 0. Everything is shifted this way. Everybody got a shift. It's just a jump to the left to, basically, get your Rocky Horror Picture Show out. It's just a jump to the left. Okay. But everything is still symmetry. It's just slid to the left. So the H is a horizontal shift. The K is a vertical shift. So when you do the matchup to that, that y equals a parentheses x minus h squared plus k, the negative is built in the formula. So when you identify h, because you want to know the vertex, The negative is always built in. So when I see this +2, I know that H is going to be -2. It's going to be a negative because it's going to be a built-in negative when you take it out. So here's what you need to remember. First of all, H is always in the parentheses with X, first of all. Second, H is the opposite sign. You got to take out the opposite sign because of the built-in negative. If you see a +2, H is a -2. If you see a -2, it's a +2. You take out the opposite. And that's how you know the difference. K has got a positive in between. So for K, K for keep. You keep the sign. HK is always going to be the vertex of the parabola. And technically, HK is going to be the most important point you're ever going to find in all of these graphs. H and K are going to be your best friends. And I know I can never finish this dang section in one day, no matter how hard I try, because it always takes a little bit of time to introduce these new topics. So we will continue on Thursday. What you need to do is make sure you're ready for your quiz on 8-1. And make sure you are ready for, practice some of the graphing on the parabolas if you want to give them a try. Make sure you can graph by hand.